Download this code from codegive.com, link in the description below. Sure. Grasshopper is a powerful visual programming tool that runs on Rhinoceros 3D, primarily used for algorithmic design. In Grasshopper, splitting and trimming geometries often involves manipulating surfaces or curves based on a defined region. Here's a tutorial that provides useful tips and a code example for splitting and trimming geometries using regions. Tutorial: Splitting and trimming with regions in Grasshopper. Overview. Splitting: dividing a surface or curve into separate parts based on a defined region. Trimming: removing specific areas of a surface or curve based on a region. Step-by-step instructions. Step 1. Create a surface or curve. 1. First, create a surface or a curve in Rhino. This will be the geometry you want to split or trim. 2. In Grasshopper, use the surface or curve component to reference this geometry. Step 2. Define a region. 1. Create a region that you will use to split or trim your geometry. 2. You can use shapes like rectangles, circles, or any closed curve as a region. 3. Use the boundary surface component to create a surface from a closed curve if needed. Step 3. Split the geometry. 1. Use the surface split or curve split component to split your surface or curve. 2. Connect your original geometry to the geometry input and your region to the splitter input. Step 4. Trim the geometry. 1. Use the trim with region component to trim your original geometry using the defined region. 2. Connect your original geometry to the G input and your region to the region input. Example code snippet. Here's how you might set this up in Grasshopper with the components. 1. Create a square surface. Use the rectangle component to define a square. Use the boundary surface to convert the rectangle into a surface. 2. Create a trim region. Use the circle component to create a circular trim region. 3. Split the surface. Use the surface split component. Connect the output of the boundary surface to the G input. Connect the output of the circle component to the S input. 4. Trim the surface. Use the trim with region component. Connect the output of the boundary surface to the G input. Connect the output of the circle component to the R input. Example Grasshopper setup. Here's a simple description of the components you would use. 1. Rectangle, to create a square surface. Inputs, X and Y for width and height. 2. Boundary surface. Input, connect the rectangle output here. 3. Circle, to create the trim region. Inputs, define the center and radius. 4. Surface split. Inputs, connect boundary surface to G and circle to S. 5. Trim with region. Inputs, connect boundary surface to G and circle to R. Visualization. Once you connect these components, you will see the original surface split and trimmed based on the defined region, the circle. Tips. Always ensure that the region you use for splitting or trimming is closed. You can use the area component to find the centroid of your split geometries if needed. Use list item to manage and select specific parts after the split. Conclusion. This tutorial provides a basic understanding of how to split and trim geometries using regions in Grasshopper. By following these steps, you can manipulate surfaces and curves effectively, leading to more complex designs. Experiment with different shapes and regions to see how they interact with your original geometry.